Could there actually be surf while we wait for El Nino to build? Let's find out. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe, ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. If you'd like to make a small donation, you can. Just hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Big Ben, Jason Odom, Elliot Harris, Nuggy Fresh, or Noogie Fresh, Russell Harju, and then a special call out to Lloyd Morrison, who donated very generously. We really appreciate your contributions, and thank you so much. And with that, let's get to work. First off, take a quick look down in the southern hemisphere. We're looking at significant wave heights across the entire South Pacific Ocean, New Zealand, Australia, Antarctica down here, the Ross ice shelf there, all Antarctic ice, and we see no seas of any interest. Yeah, there is an area of, 26-foot seas. They're all aimed due south, penguin swell only, and otherwise the South Pacific Basin is pretty clear for the moment. We'll do a quick look at current conditions starting in Northern California. We're looking at the buoys. We're looking for any hope of swell energy. This is a graph of all the energy present in the water, period across the bottom, and height in feet over on the side here. Up here, 33.3 second period. I mean, if there was any energy here, that would be really long period energy, but there is none. But we see a little bump here somewhere at 16 seconds and some other stuff in the 11, 12 second range. And then this goes the whole way down to 5 second period. That'd be just like pure, pretty much unrideable wind swell. And we see a bump here at about 9 seconds. Put this all together, primary swell, 4.3 feet at 8.8 seconds from 329 degrees. That's that northwest wind swell. Then buried in the middle of some of that is a residual southern hemi swell, 2.4 feet at 11.8 seconds. It says 244 degrees, but it's more like 200 or something like that. Yesterday there was actually some rideable surf in Santa Cruz, waist high sort of thing. If you were patient, sat at the right place, and maybe even a waist high, chest high peak or so. And I heard rumors there were some bigger waves a little further up around the coast. But today we go down to Santa Cruz. Again, we're looking just a tiny little bump of energy in the 12, 13 second period range. No wind swell. Put it all together, 1.5 feet at 12.4 seconds from 209 degrees. That'd be surf that's, thigh high, something like that. Then maybe some background energy mixed in, 0.6 of a foot at 16 seconds, and really not noticeable. Now here's where the fun begins. We're looking down Southern California, Point Loma South buoy number 191. All the energy hitting there. Oh my gosh, look at this. And it was even bigger a couple of hours ago. This is the swell from Hillary sliding into select breaks in Southern California. You've got to be a detective. You got to know where to be. But there is definitely surf down there. Primary swell 5 feet at 13 seconds from 170 degrees. It's probably even more like 160 to 156 degrees, something like that. Surf from the primary swell, that'd be 6.7 feet. And there definitely were waves, even maybe a little bigger than that, a couple hours ago. In fact, we can scroll down here. You can see the peak of the swell, at least when it hit that buoy, was right around noontime, starting to fade a little bit. It took a little bit to work its way up further north into California, but the peak of the swell is hitting most spots that can get the swell, and it is a very fine thread to squeeze through this needle. We'll get into more on that in a minute. Then we go over to Hawaii, again looking at all the energy, just little bits, biggest swell point, or biggest period, 0.6 of a foot in the 12 to 13 second period range. Primary swell 1.2 feet at 13 seconds. That would put surf at 1.5 feet, so thigh high, and that's about what it's doing on the South Shore. So we're going to go back in time. We're back Monday. What is that? A week ago, the 14th of August. So there was a gale that developed right here, 20-foot seas. I'll roll this out, see if we can get it to, there we go, 25-foot seas, aim north. That was on Tuesday. Did I get a higher reading than that? Yeah, little tiny area, 26-foot seas right down here, 26.5 feet. The highest seas over this the whole domain, and they're centered, that little red dot right under there. That swell is radiating north now and is expected in during this work week. Again, nothing very big. We're talking waist, maybe chest high in the peaks sort of thing. But at least there's something happening. It's not dead flat. And we'll run this out through the rest of the week. There was another system that developed in the far southeast Pacific with bigger seas, like 27 foot, but they were all, the fetch and all was aimed due east. Yes, for Patagonia, maybe up into Peru, some swell will result there, but relative to California and even Mexico, nothing expected. And then after that, let's see, we're on Saturday, we'll go into Sunday, this fetch falling south, and that is where we are at right now. So let's go start looking to the future. Is there something more coming? And we kind of hinted at it in the title of the video. Again, it's a forecast, so don't believe it, but we're going to start by looking at jet stream level winds. These are winds up about 30,000 feet to help support the formation of gales. When those gales form, the jet helps direct their track. This is the northern branch of the jet. This is the southern branch, Antarctica down here. You can see bits of New Zealand there and Australia over there. Chile, Peru, South America over here. We're looking for a push in the jet to the north because what that helps do is create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area, get groomed out and eventually turn into swell. And of course, swell when hit your beach turns into surf. All right, so we're looking for a trough. We don't see anything. We're into Tuesday. Then on Wednesday, right here, you see the jet start pushing to the north, and that's where you can get that clockwise rotation. And not super strong winds. So this is the 18Z run of the model. This morning's run, it was quite a bit stronger. And also San Diego here about 117 west. So this is the cutoff, but there is some fetch forecast as we get into Thursday, and then maybe another little pulse on Friday into Saturday with, what is that, about 120, not even 130 knot winds aimed off to the north. So real south angled swell, or at least a gale is forecast in the very south-angled portion of the California swell window, and certainly for Peru and Chile and up into Central America and Mexico. And then by Sunday, that's all over, and we are a week out. Let's go take a look at the effect of those winds, or the effect of the jet stream on winds down at the ocean surface. Here we are, surface level pressure, surface level winds. We're really blasting through this because there's really nothing forecast for a couple days until that trough kicks in. Then on Wednesday, you see a little gale far down here. Now, the Antarctic ice line's about 64 south, so right there. So just a little bit of 35 knot winds eking north, building to 40 knots on Wednesday night. That would be the 23rd, and pushing almost to 45 knots as we get into Thursday. The swell window cut off for Southern California right over here, and continue building with a good fetch of 40 knot winds aimed off to the north. This is on Thursday night into Friday, and then pushing out of the swell window. But notice this broad fetch and even some secondary fetch redeveloping on Saturday with up to 40 knot winds pushing off to the north. And yet another pulse. Now, this is about as rare as they get when you actually get fetch out of the swell window, pushing off to that'd be the northwest a little bit. So just maybe, and that could push a very southeast angled swell up into Southern California with a little bit of luck, and certainly good for Mexico. And that continues for 180 hours out. So there is potential. Also note, under New Zealand here. You can't hardly see it, but a little fetch. The models have been teasing at something going on over here with the jet stream actually kind of lifting north. So maybe there's some hope there too. Still, it's a week out or 5 days out for the Southeast Pacific thing, but at least there is hope on the charts. Let's go take a look at the significant wave height models. So here we go. As expected, nothing happening right now. It's not till, what is it, Wednesday or even maybe Thursday. There we go. Little area of 20, 22, 24, 26-foot seas, 27-foot seas, building to 28 feet on Thursday night and to 30 feet later on Thursday night. And continuing north. Now, this is pretty much out of even the Southern California swell window. Certainly good again for Peru and Chile and Mexico and all that. We know there's another fetch right now, only 20-foot seas forecast. Oops, 20-foot seas forecast. Oh, yeah, the model does this strange thing. I'm never quite sure what's going on or what's causing it. So, but at one point, there was up to 28-foot seas forecast. So, again, it's a week out. We'll keep our eyes on it. But it looks like there is hope in the Southeast Pacific. Then we're going to take a quick look at the jet stream up in the North Pacific. As of today, well, the jet is way up in the north, up in the Bering Sea. Again, let's see, Baja, California, the U.S., Canada, the Aleutian Islands here, Japan, the Kuril Islands, Kamchatka up here. So really nothing going on. We're just going to blast through this. But as we get into Tuesday, 22nd of August, the jet kind of rebuilding, kind of dipping south, trying to make a trough. Now in the Northern Hemisphere, it's a counterclockwise circulation that gets created, which is the hallmark of low pressure in the Northern Hemisphere. And the jet looking reasonably decent. As we get into Friday, a little bit pinched off trough there, and Saturday, nothing real clear that suggests obvious swell production, but what we're looking for is, one, effects of the season. I mean, it'd be pretty typical to see the jet kind of waking up, and this looks actually a little bit better than normal for this time of year. So we're also trying to tease out whether there's some hope of El Nino having effects in the atmosphere, feeding energy into the jet. I'll give it, a little bit, maybe a 20% push here. So there is some hope. Let's go look at the effect down at the ocean surface. We're just going right to the wave model here. There is really nothing to see, not even any 20-foot seas. A little bit of a gale. What's that? Get 16-foot seas out of it, something like that. That's on Friday, Saturday of next week. And then maybe a little bit more beyond that, but nothing of any real interest yet. But the jet is trying. All right, and then we're looking for wind swell next up, or actually we're looking for no wind swell. Why would you want that? Well, we don't really want any winds over the Pacific along California because we want the ocean state to be calm. We want the sun to start baking the ocean surface and warming it up, just to get us sort of in a feeling of a more normal for this time of year pattern, which certainly was the case in Santa Cruz yesterday. I mean, water temperatures were warm. It finally felt like, hey, it's summer and it's normal for this time of year. Downright balmy with a wetsuit on. All right, so anyway, for Sunday, we have high pressure here in the Gulf of Alaska driving and low pressure inland. Some of that Hillary down here, but otherwise heat low pressure tightens up the isobars between the high and the low, creates north winds, mainly along the Oregon coast. As we get into Monday morning, 30-knot north winds along Cape Mendocino area. That should generate some wind swell. Trades for the Hawaiian Islands at 15 knots. But as we get into Tuesday, all that dissolves pretty quickly back to a light wind pattern, which is really what we want to see. In fact, dead calm winds here along central California. And trades for the Hawaiian Islands again at 15 knots. Wednesday, pretty much the same. A little bit of northwest winds off of Cape Mendocino, but placed in the correct place. And all earlier this year, it was like way down here somewhere. Up here in this southern Oregon, northern California thing, that's about where you'd want to see it for this time of year. So we get into Thursday, trades continue 20 knots, maybe generating a little bit of wind swell. Light trades for the Hawaiian Islands. Friday, things just pretty much, the high, notice, regroups out here. light winds more or less for the California coast. Trades 15 knots for the Hawaiian Islands. Saturday, a little bit of the high sinking south generating, again, this pesky south displaced northwest wind pattern along central California. And as we get into Sunday, that holds. That's a week out. And trades continue. So no wind swell real generation there, but that might kind of create a little bit of upwelling sort of thing. And we really don't want to see that at this point. All right, so surf forecast, local surf forecast. Half Moon Bay, it's all wind swell, 2 feet, maybe bumping up to 4 feet late on Monday, and then just hanging around basically flat to knee-high sort of thing. You can see the swell pattern here, 4 feet at 9 to 10. This is swell height. This is swell period. 4 feet at 10 seconds, and then down in the 2 to 3 feet at 8 seconds, which is just really nothing. But we know there is south swell coming from the gale that was there in the southeast Pacific, 5 or 6 days ago. So we go down to Dana Point. This is more protected from the wind swell. Wave heights, 2 feet, 2.5 feet, that sort of thing. But what you can see here, and this is also valid for Northern California. See the period? This right here, this 15-second period stuff, this is the Hillary swell. But then as we get into Tuesday and Wednesday, 15 second, 14 second, 13 second, that is the southern hemiswell. Swell size, 1.8 at basically 14 seconds. That gets you 2.5 foot surf. So waves for a couple days in the late Tuesday, Wednesday, Thursday sort of thing. And then it all fading out as we get into the weekend. The South Shore of Oahu, pretty much shut out from whatever minimal action there is. Surf sizes in the 1.5 foot range. Swell sizes 1.5, maybe 2 feet at 10, 11 seconds, then dropping to 9 and 8 seconds. I mean, we're pretty much either waiting for something miraculous to happen in the southern hemisphere, which maybe it will happen, but really the focus is turning more and more now to the North Pacific, which for the current week is quiet. And just for fun, a quick look at Hillary and what Hillary did and how and why the swell was produced and why it is the way it is there in Southern California. We posted this on Instagram. If you don't follow us on Instagram, you should. You can find links pretty easy. I think we're Stormsurf, so it's not too hard to find. All right, so here is the forecast, or here's the actual track of Hillary. Peaked out with winds 115 knots, which is about 135 miles an hour. And you can see the track there, and then going over Ensenada, currently over Southern California. All right, now the issue is swell window, right? Okay, hurricane does not produce swell equally on all sides of the hurricane. In fact, you can see this little purple line going like this. It's only on the east side of the storm because winds rotate counterclockwise around the storm. So you got to have fetch aimed in your direction. If you're up here, it's only on the east side of the storm, all right? Now, the problem with the east side of the storm is, well, you got a big old chunk of land out here in Navidad and some other little obstructions along the way, and then you get up in here and you have the Channel Islands, all right? So this is the Great Circle Path. Because it's such a short distance, it's basically a straight line. There's one of the Channel Islands there that cuts it off. Basically, the window was started up barely into Malibu, Long Beach. The other window right here, this goes into San Diego, right there, okay? And all there was this little, see that red arrow, that gap from, this is the path, you got to be on the east side of the storm, and any fetch that is east of these lines gets blocked by land right there. No swell will get through. So I went and measured this all out. I mean, this is sort of the cartoon version. I did it all way more detailed somewhere else, but there was like 37 nautical miles of fetch right in this area. And if you use this line here, I think at one point we got maybe 87 nautical miles, which is a tiny little hole to shoot a bullet through to get in up here. The good news is it was really close. It wasn't that many. It wasn't that far. I don't remember. It was 600 or 800 nautical miles, maybe 1,000 miles or 1,200 down here, something like that. So short. The net result: short little blast of swell started hitting early this morning down in Southern California. We thought it would peak at about 3 or 4 p.m. and that's about exactly what it did. Top spots, I think I saw some waves, maybe 2 feet overhead at top spots, but very fickle. If you weren't at an exposed break that had great south-facing direction, you weren't going to get any of it. It was just totally hidden. And now the swell is already starting to drop out. By Monday morning, it's going to be all but gone. And with that, let's go take a look long-term. What's going on with the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. These two oscillations are the primary determiners or influencers of storms and swell production going out to 4 weeks, out to a year. We'll start by looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. There's two phases, active and inactive. The inactive phase basically is a high-pressure system. It does nothing. It steals energy from the jet stream and does not support storm development. The one we're more interested in is the active phase of the MJO. It is like a low-pressure system. The MJO rotates west to east around the equator. Okay, active phase on one side of the planet, inactive phase on the other. The active phase, when it starts moving into the West Pacific, because it's a low-pressure system, it draws warm, moist air from the ocean surface high up into the atmosphere. That gets caught by the jet stream, energizes the jet stream more in the northern hemisphere than the southern hemisphere, but still affects the southern hemisphere. And a more energetic jet stream creates troughs, which create storms, which create surf. The other good thing the active phase does is that it helps reduce trade winds. Trade winds are basically generated by high pressure, both in the northern hemisphere and the southern hemisphere. When the active phase starts pushing across the equator, what it does is it reduces pressure, so it reduces trades, if not it's out and out reversing them. So trades typically blow from east to west. Active phase can take those winds, turn them from west to east. That takes warm pressure that's all piled up in the West Pacific by the normal trade wind, starts pushing them to the east, and they travel across the Pacific, not on the surface, but underneath the equator in a thing known as a Kelvin wave. It's basically a ball of warm water. And that takes 4 months to make it from the West Pacific to the East Pacific, eventually erupting along the coast of Ecuador there and creates a warm water slick. If you get successive active phases of the MJO, and as of so far we've had 5 of them since January, that can help usher in El Nino because it starts really warming the waters off of Ecuador, which anyone that's been following this knows that's exactly what's happening. So, let's dive in. We're looking for signs of the active phase of the MJ. This is data from the TAA buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they also have wind sensors on the buoys. So we can just look at this chart. This is the East Pacific here, West Pacific here, equator there, date line right there. Arrows indicate wind direction and speed. Pretty strong trades here in the East Pacific, pretty strong trades in the Central Pacific. Look at that, a little bit of actual westerly winds here in the West Pacific. That's New Guinea down there. So this suggests maybe the active phase of the MJO is in control. Or if El Nino is building in the atmosphere, the active phase kind of disappears and you just get this perpetual westerly wind kind of pattern going on. But it's not the actual winds that matter, it's the anomalies. Difference from normal for this time of year. Looking over the East Pacific, the arrows are going nowhere really. Yeah, maybe, and it's just 5 degrees north and south of the equator. I'm looking at this one arrow here. It's barely on the 5-degree line. Little pieces there. We'll say light westerly anomalies. Over the Central Pacific, neutral, but there's some westerly anomalies. In the West Pacific, westerly anomalies. So, in effect, it looks like the active phase or potentially an El Nino base state is setting up in the atmosphere. And if you've been following this channel, you know that we are super intent on trying to see the El Nino signal getting a firmer grasp in the atmosphere. Yeah, it's been strong in the ocean in terms of Kelvin waves, active phases of the MJO, creating Kelvin waves, warm water, all that kind of stuff. But we haven't seen a whole lot of evidence in the atmosphere yet that El Nino is taking hold. That is, there's two components to El Nino, in the ocean and in the atmosphere. The oceanic signal has been extremely strong. The atmospheric signal has been extremely weak. They need to be coupled. Now, the other thing is we think as we get into the fall season, that's typically when this coupling is the strongest. We were very excited early this year. We thought we'd be in super El Nino status. We thought this would all be coupled as we pretty much got into June, but then things stalled. And we're still somewhat in that state. For the next 15 or 20 minutes, we're going to talk about how strong or weak that coupling is. So we have westerly anomalies today. What's been going on in the past 5 days? This is 850 millibar zonal or vector wind anomalies. Fancy words for just the east-west component of the wind. This is the whole planet. South America, Central America, Hawaii, New Guinea there, the equator right there. Okay, dateline right there. It's really just this area in the West Pacific we're most interested in. That's what fuels the Kelvin waves and helps feed the Walker circulation, that sort of stuff. So right now we see a lot of westerly anomalies off of South and Central America. That's actually a good thing because there's been easterly anomalies there for a couple of weeks. This will actually help fuel the manifestation of multiple Kelvin waves that are erupting in this area. And the warmer this water gets, the better for feeding the atmosphere. But we still see a little bit of westerly anomalies here on the 14th of August. Same thing on the 15th, 16th, 17th. A little bit weaker as of the 18th. West not looking so particularly energetic at the moment. 850 millibar zonal wind anomalies forecast out 2 weeks from the GFS model here. This is what has been going on. This is the forecast. The reds and yellows, westerly anomalies. That's what we want to see. The date line running right here. So the Kelvin wave generation area starts about here and goes to about over here. And we see that we've actually had westerly anomalies over here since sometime in June, and they've been going and going, and now you see about 2 days ago, they pretty much fell apart. Here's our strong westerly anomalies in the East Pacific. This is California's basically 120 west. So this is on the equator. So that's still in play and forecast to continue for about a week. But just today, I mean, the prior runs of the GFS model said, these easterly anomalies would continue for about a week and then we'd have westerly anomalies. Now the GFS is kind of like freaked out. Shows easterly anomalies for the next 2 weeks. I'm not sure I believe it. We'll need another day or two to see if this holds. But for right now, I'm considering this an anomaly. So here's another view of it. The reds and oranges, westerly anomalies. Let's get ourselves, there's New Guinea right there. The equator goes right across like that, and Ecuador's right there. There's the Galapagos. So you can see westerly anomalies over pretty much the entire equatorial Pacific. Let's put this in motion and see what happens. As we go, slide into here, westerly anomalies very strong in the West Pacific as we get into Thursday, the 24th. Of August, and patches continuing into Saturday. I mean, this doesn't look as bad. And then another pretty good blob of westerly anomalies as we get into the 28th. I mean, this just doesn't look as bad as what we saw on that previous run. And this is the 18Z run of the model right there. So this looking, I'll just sort of blast through. There is your little bit of easterly anomalies, but that's not till almost a week and a half out. And there we go. Then it all sort of falls apart. Wondering if the GFS model just hadn't lost its mind for a minute, but who knows. Next up, outgoing long wave radiation forecast. All right, if the active phase of the MJO is a low pressure system, well, it's going to generate clouds, right? The inactive phase, if it's a high pressure system, produces cloud-free skies. So this is a model of the amount of cloud cover over the ocean. South America, Central America, Hawaii, New Guinea, equator there, dateline there. Yellows and oranges mean more sunlight reflecting off the ocean surface. One can loosely equate that with the inactive phase of the MJO. So today, and this is the statistic model, inactive today, 5 days from now, 10 days from now, 15 days from now. Certainly looks like the inactive phase of the MJO is to set up. The dynamic model, the GEFS model, we'll get this centered right there, suggests, yeah, the same thing, but maybe much weaker 10 days from now and 2 weeks from now. So a bit of a disparity here. Phase diagrams for the same two models, statistic model here, dynamic model here. How do you read this? Well, the MJO, active phase, this just maps the active phase, moves from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific, over the East Pacific, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is today, so it's basically over Africa. The further the dot is away from this circle, like out there, the stronger it would be, but no, it's pretty close. So a very weak active phase, pretty much on the other side of the planet from where we want it to be. Forecast moving, 3 different members here suggest it moving to the Indian Ocean 2 weeks from now. The GEFS model, pretty much saying the exact same thing. So no immediate hope from the active phase of the MJO for the next 2 weeks, and that's kind of what everything looks like. The easterly anomalies that we saw probably look like the inactive phase of the MJO trying to get a toehold over the equatorial Pacific. Exactly what we don't want to have happen, because the El Nino development has been pretty much stalled or just limping along here all through July, and now pretty much all through. Yeah, we've had a pretty good little run of westerly anomalies, but nothing over the top. Nothing, if you were in super El Nino status, it should be ripping right now, and instead it's limping. That certainly smells like not a super El Nino, and it almost smells not like a strong El Nino. But let's dig deeper. And another view going out 40 days, again, cloud cover precipitation potential. Okay, 8 different panels, 5 days of panels, South America, Central America, New Guinea there, equator there, dateline there, Kelvin wave generation area here. Oranges and yellows suggest cloud-free skies, inactive phase of the MJO, and we see that's kind of the case over the Kelvin wave generation into about the 4th of September, and then a little bit of cloud cover starts building, steadily building. Looks like the active phase of the MJO is somewhere around. Now, this is the upper level, Jetstream level, and takes about a week, so it's running about a week ahead of what happens down the surface. So this says the 9th of September, so maybe the middle of September, active phase shows up, and then theoretically we're in business, but we've all heard that one before. So then we go to the CFS model going out a month, all right? This is, again, reds are westerly anomalies. So we're not looking at precipitation, we're looking at winds now. The reds are the active phase of the MJO. In fact, the black line there signifies the active phase, the dotted contour, the inactive phase. Now, this is the east and west anomalies over the entire planet. All we care about is the far west Pacific. That starts at 125 west, so you just go right up the chart here, and ends at about 170 west, so right here. You can see somewhere in there, it was July, westerly anomalies started. They were pretty much continuous up to about today. Now, this little red dotted contour is an equatorial Rossby wave. It is forecast, or it is developing, pushing over the dateline Kelvin wave generation area, and that looks to be what's going to feed, at least according to the CFS model, some easterly anomalies for a little bit here. Then theoretically westerly anomalies return, another little pulse of easterly anomalies as we get to the beginning of September. Then by about September 3rd or so, westerly anomalies fully take over. Now notice westerly anomalies are forecast holding on the dateline here too. So really, the easterly anomaly pattern, according to this model, is not nearly as bad as what the GFS model is suggesting. So a bit of a disparity here. All right, so now we're going to take one other look. This is the CFS model going out 3 months. The forecast is up here. What has happened is down here. Now this is outgoing long-wave radiation again, cloud cover, propensity for precipitation. We're looking for signs of the Walker circulation developing, okay? And you have to go dig back a couple of videos, but basically it's like a massive low-pressure system that sits during the development of El Nino. Instead of sitting over the maritime continent, it sits smack over the dateline type region, the central Pacific, and sucks warm, moist air high into the atmosphere and creates cloud cover. So the blues are cloudy skies. This model, looking at this, suggests, well, and this is the forecast here. Oh, I'm sorry, the date line runs right up the middle. So the Kelvin wave generation area starts right here, 125 west, and goes to about here, 170 west. I'm sorry, 125 east. Anyway, so you can see, looking back at past, you see this sort of scattered blue pattern building, and then forecast getting incredibly strong starting basically today and continuing through the end of the model, through the end of November. Let's look at something else. Here's a satellite-based view of what's actually happening. Again, dateline right here. Now the reds and oranges are dry air. This is going back a year. So this is the La Nina signal, right? Dry air over the dateline. The upward circulation over the maritime continent at 120 east. And then come right about May, boom, that all shut down. La Nina died. And you see the building blue pattern of clouds building over the dateline, but the signal pretty weak. I want to see these blues as intense as these yellows and oranges are, but they're not there. Now, the one good thing that is sort of happening, you see this building dry air pattern trying to get going over the maritime continent. This all suggests that El Nino, and specifically the Walker circulation, is trying to get organized, but it's not. The longer it takes to get going, my guess is the weaker the El Nino will be. And right now it's limping along, but it is not robust by any stretch of the imagination. One would think that by the middle of September, this should really start becoming solid blue in this area. All right, so enough of that. Let's go look at zonal wind anomalies. All right, the same sort of forecast. The yellows and oranges, westerly anomalies. The blues, easterly anomalies. We want to see the westerly anomalies building right on the dateline area, and that's what this model suggests. Now, here we are today, and you can actually see, starting back in July, westerly anomalies pretty consistent, but then here we go again with this pesky little easterly anomaly thing going on. I thought it was an equatorial Rossby wave, and I guess that's what this is kind of trying to show, but seems like that's not a particularly strong correlation. Let's overlay the MJO. Okay, now this really says it. The dotted contour is the inactive phase of the MJO. So going in the past, active phase in May, the solid contour here. Another active phase that went through July and August. That's been creating this whole stretch of westerly anomalies. Now we have this inactive phase of the MJO. Forecast going just like what we thought from some of the other charts, till about mid-September, September 13th. But even with the inactive phase, give it about not even a week, westerly anomalies are supposed to start building and continuing. And then when we hit September, boom, the monster awakes, supposedly, with super strong westerly anomalies and pretty much continuing on off the chart from there through November. This would be the really beginnings of a solid El Nino signal in the atmosphere. Now remember, we've said it and we'll show you in a few minutes. The ocean signal is strong. We're waiting for the atmospheric signal to be strong. We're thinking we still got about another 2 weeks. And you know what? We've been saying that week after week after week now since July, and still we're just getting lulled along into, okay, another 2 weeks, another 2 weeks. So just keep that in mind, that this model, I think, is teasing us a little bit. So let's go down in the ocean. You guys know this drill pretty well by now. This is data from the TAA buoy array, the series of buoys strung across the equator used for monitoring El Nino. We're looking at the ocean part of this passion play right now. These are the anchor lines on the buoys. The X's are sensors. The sensors collect subsurface water temperature. We're looking for Kelvin wave movement and the balance of warm water across the Pacific. All right. West Pacific here, East Pacific here. 30 degrees centigrade warm anomalies, basically no change. Big pool of it right here. The 29 degree isotherm unchanged the past week right here. The 28 degree isotherm unchanged. The good news is the 24 degree isotherm was up at 25 meters. It's starting to get thick again, suggesting something's going on, maybe more warm water starting to build in the East Pacific. Now, this is the actual temperatures. We can look at the anomalies, the difference from normal for this time of year, and it paints a better, clearer picture of what's going on. Okay, clearly a big ball of warm water still present, not nearly as warm as it was, but still quite up to 5 degree centigrade anomalies. That's like 7 or 8 degrees above normal. In the East Pacific going to, what is it? I think that's 130. Yep, 130 west. So that's probably 2 months, month and a half to 2 months worth of warm water right there. So if we're in middle of almost the end of August to September, at least through October, warm water here. Now, the good news is, this is new, a pocket of 3 degree anomalies showing up here, and another building Kelvin wave here, driven by all those westerly anomalies that have happened in July. So there is, and this will probably take 3+ months to get over here. So that is, so August to September, October, November. So we have plenty of fuel for our El Nino right here. That is good news, and no cool pool of any magnitude showing, and the pipe is still open in the far West Pacific here. Let's go look at another image. This shows it. This is satellite-based data. It's not actual temperatures, but we'll get into that in a second, but clearly showing the warm pool actually going out to almost 138 with piles of 1 to 2 degree anomalies, and here's your next building Kelvin wave right here at 2 to 3 degrees, right? 1, 2, 3, 4, 1, 2, 3, 4, 2 to 3 degrees right here. So again, warm water is not an issue. Cold water is not an issue. The ocean looks great. Honestly, it looks wonderful. We're just waiting for the atmosphere to respond. Everything it needs is sitting right there. I think what is happening is the lingering effects of La Nina. They're just hanging on, and 3 years of La Nina is not going to be canceled out in a day or in a month. It's going to take a couple of months, and I think we're in that process. I think we're right there. All we need is something to push us over the edge, and probably the seasonal change and a little push from the active phase of the MJO in mid to early September, and we'll probably be there. This is the satellite data used to build that previous image. Okay, these are not temperatures. Let's get ourselves oriented first. Chile, Peru, Central America, Hawaii there, the equator, dateline, New Guinea there. These are ocean heights. What do you mean by ocean heights? Well, so you take a satellite, you measure the height of the ocean, the sphere of the ocean. Take out the wind waves, take out the waves, the swell, the tides. And is the sphere of the ocean higher or lower than normal? If you have warm water at depth, it expands. It'll create a bump on the ocean surface. Cold water at depth contracts. You'll get a dip in the ocean surface. This again says, well, warm water or positive anomalies all off of Ecuador going out to, where is that? That's about 142 west. So that's months of warm water at depth there. And you see it. This is from Kelvin waves. They come here, they slam Ecuador, and then they spread north and south. A clearly defined warm pool, El Nino-ish in style. Well, clearly El Nino warm pool in control. And then here's our newly developed, weak but still developing Kelvin wave here on the dateline, and a steady stream of warm water feeding into the existing warm pool. A little bit of a break here, but you can see this is the warm water coming through the maritime continent, and then it falls to depth here, pulls up, and if the westerly anomalies are strong enough, that's what gives it momentum to make a legitimate Kelvin wave pushing east. We think we have one here, and the path is wide open, so not looking too bad. Upper ocean heat anomalies, same sort of deal. This puts things in perspective. Time over here going back a year. West Pacific here, East Pacific here. Last September, cold water, the La Nina signal in the East Pacific. Building El Nino signal in the West Pacific. We got a Kelvin wave, now change of season, right? Push, fed, and that's really when the active phase of the MJO wakes up, when you get into fall and winter. Active phase created a little bit of warm water pushing across the Pacific, really put a ding in La Nina. Another one in January, driven by the active phase of the MJO. That was number 2. Number 3 in March, number 4 in April, number 5 in May. Then we had our pause, and then here we go with our next one, and a little bit of warming here showing up. So all this looking pretty good, suggesting a large reservoir of warm water. Notice back here, the temperatures still are not cold at all. And during super El Niños, we've seen that where it gets cold, and it really starts like somewhere in June. I think Ben was the one that provided some of those charts. You get cold over in here, and that pretty much says, okay, El Niño's over. We're not seeing that. I mean, there's still this kind of lingering thing. It almost makes you wonder if, and this is really putting it out there, are we heading for a 2-year El Nino? Like maybe this is a moderate start, but maybe it will linger on. I mean, that's probably too much to hope for, but it's a thought. All right, sea surface temperature anomalies. Great news here. Let's start with getting oriented. Chile, Peru, Ecuador, the Galapagos, Central America, Hawaii, right there. All right. With the development of westerly anomalies over Ecuador, look at the response in water temperature. We have this massive pool of warm water subsurface. Then you get weak westerly anomalies or just neutral trades. Boom, the warm water starts blooming and then does get caught by the normal trades and now is building out to about 140 west. We want to see these brighter oranges start building further out this way. Maybe a little bit too early, but that's coming. So the point is, the warm water signal really has just this week woken up significantly. Point number 2, warm water building all off of California. The last of the La Nina cool pool is fully pulled away from the California coast now, and it's just lingering south of Hawaii. And if the high pressure system stays weak enough and trades stay light, we think this will collapse pretty quick. That would be a good sign too for at least the change of season and more fuel for El Nino. Sea surface temperature trend for the last 7 days right here on the equator. Reds are warming temperatures. This is good. We see a whole string here, not surprising given what we saw down here with that. Warming temperatures all along here. A little bit of cooling here off of Mexico. That is from Hillary for sure. And then we still have our warming temperatures with the collapse of the cool pool off of California. Thank goodness, bring it on. So things looking pretty normal for a change. And then finally, the backed off view here, very warm temperatures continuing along and then out. The official El Nino, so the Nino 1.2 region, we'll get into this in a minute, but there's an area called Nino 1.2. It's right in here. The official El Nino monitoring region, the Nino 3.4 region, 5 degrees north and south of the equator from 120 west out to 170 west. So right here. Now notice, most of this warm temperatures are not in the official El Nino monitoring region. The trades have to gently push them along, and the Walker circulation has to get going, dragging warm water from here out this way more. And so if the center of the Walker circulation is somewhere right around in here, then you get the high spike in sea surface temperatures in the Nino 3.4 region, and that is what's used to determine how strong an El Nino is. Sea surface temperature anomalies in the Nino 1.2 region, that area right there by Ecuador today, 3 and 44 thousandths of a degree above normal, looking quite solid. In fact, just a couple days ago, we were up close to the peak, as high as it's been. So this is great, suggesting a large reservoir of warm water at the surface. But again, this is not the official El Nino monitoring region. This is, and as expected, we're slowly heading upward at 1 point and 122 thousandths of a degree above normal. So, neutral is here. You're in El Nino if you're half a degree above normal for, 5 consecutive 3-month periods, which we're getting there. You're in moderate, so this is weak El Nino. Moderate El Nino starts at 1 degree. So we're into the moderate El Nino threshold. Strong starts at 1.5 degrees, and super El Nino starts at 2 degrees. I don't think we're going to get there. We're trying to get to 1.5 degrees or better. Right now, things are looking good for pushing in that direction. So do a quick little comparison here of previous El Nino events. Here's our current El Nino event, looking quite solid. The last of the La Nina cool pull right out here. Now let's go to, this is 2015. I'll move myself out of the way so you can see the date right there, 2015. So we're actually way ahead right now of the 2015 El Nino in terms of the warm water signature. But no, in 2015, the temperatures are warmer out here than our current event. We're so eastward displaced. We're east of the official El Nino monitoring region. And I think there's something to be said for being extremely eastward displaced, but we'll probably have some debates about that. I'm not going to get into it right now, but clearly we are stronger than 2015, which was a super El Nino, and way more eastward based. Now let's go look at 2009. We're way beyond that, and I think that came out to be a strong El Nino. Okay, so we're just trying to put things in perspective. Now, here's the really sobering view. We're going to go look at 1997. Boom. Just completely blowing the doors off of what we're doing right now. Still, right now, pretty respectable, but you can't even begin to compare. Also, notice the cool pool still existed. This is as of August 19th, south of Hawaii, whereas, yeah, it's a little bit bigger here this year. But sobering view. We're actually doing pretty well, all said and done, assuming we get to the magic place where we need to be with the Walker circulation getting in control. Sea surface current, another way to get sort of a sense of what's going on with the Walker circulation. Looking in the West Pacific, there's New Guinea there, the equator's right here, maritime continent, all the little islands, all the heat there. You can see the current just raging, going strong, building compared to weeks past. Now let's slide over and look at the East Pacific right here. You see a strong current going this way. The dividing line between the two, last week it was, I thought it was like right on the date line. Looking at this, I'd say the dividing line right now is somewhere about there, and that, you can't see it on the screen, but it's about 160 west, due south of Hawaii. So the westward side has built some over the past week. Eastward, still solid. Center of the Walker circulation, if I were looking at this, would be theoretically somewhere right along here. I think this is good news. So what does the atmosphere really think is going on? We'll look at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin over the maritime continent, Indian Ocean. When pressure is lower in Tahiti, which is exactly where you kind of want the center of the Walker circulation to be, the index will go negative. Today it's 3.70, so it's neutral. And this has an update in 2 days. There's some maintenance going on the server, but you get the general idea. Looking back a couple of days, we've been toggling around, hovering right around neutral, but prior to that, a long run of negative numbers. I think this is all talking to the pending development of the inactive phase of the MJO and a little bit of softness in that pattern. 30-day average minus 11.93. We were up to 13.48. Okay, now we're losing a little bit of ground, but looking back, where were we a month ago? We're positive 3.16, so we're in a pretty good place. 90-day average, well, we're minus 7 points. So this would be the active-inactive phase indicator suggesting we were in the active phase. Now we're starting to move out of it, which makes sense. This is the El Nino, La Nina indicator. You want to see this down at minus 15. We're at minus 7.47. Where were we a month ago? Minus 6. So basically a steady state El Nino. We're inching along, but again, we need something to push us to really activate El Nino. All the fundamentals are there. I mean, honestly, the fundamentals are phenomenal with all that warm water and multiple Kelvin waves and the current and everything going on. We'll get into that in a minute. We're just waiting for the magic to happen to send this thing into overdrive. Here's the 30-day moving SOI graphed out. Positive up here, that's the La Nina territory. This is El Nino territory going back in time, January 2021. You can see, and the downward spikes are the active phase of the MJO. Upward spikes, the inactive phase. Clearly, during La Nina, the inactive phase of the MJO beats the active phase every time. But then we hit January 2023, massive, just long-running active phase. We've had our little bump. We're heading down, then heading back up again, we think, for only 2 weeks, and then my guess is we're going to start plummeting from there. But again, that's just a guess. So the forecast for sea surface temperature anomalies in the Nino 3.4 region from the CFS version 2 model. This is the official El Nino monitoring region. So today, let's see, in July we were 1.1 degree above normal. We're in August. Mid-August would be right about here. This says 1.2. That's pretty close to where we are. And this says as we get into September, temperatures should start taking off by October up to 1.7 degrees and then 1.95 degrees in November. So that'd be the top end of a strong El Nino. Now, this is actually down about 2 days ago. It was up at a 2.1, and at one point it was at 2.4. So this is sort of coming down to earth a little bit. I think the model is sensing some of this weakness that's been going on in the month of July in terms of the development of El Nino. And then we move to the PDF corrected version. This is even less optimistic. This is suggesting a peak at 1.5. My guess is we'll end up somewhere in the middle there, something 1.7, which would be, again, so weak El Nino from 0.5 to 1 degree, medium from 1 to 1.5 degrees, strong from 1.5 to 2, and then super El Nino 2 to 2.5. No hope of a super El Nino. I think we're looking at a moderate, strong El Nino as of right now. Let's go look and see what other models say. The Concensus model updated this week. Let's see if we can pick out what's here. This is the statistic model average. Oh, and let's get ourselves oriented here. So May, June, July. This is the observation. Okay, right there. And then the forecast going out. We're just going right for peak values, somewhere around November. Consensus model says, the statistic models say temperature's 1.1. That's really low. There we go. The CPC consolidated says 1.25, so that's only a moderate El Nino. The dynamic models are all up here suggesting 2 degrees to, let's see if we got that, 2.05, so a strong El Nino. In fact, let's pull down here. So these are all the dynamic models. The months are across the top. You can look at all the models. The average of the dynamic models, 2.06 degrees in the November-December timeframe. The CFS model, which we've been using a lot, suggests 2.07. Just looking at all the values here, pretty much the CFS sits right in the middle of the batch. There's some here 2.4, I think that 2.2, 2.2, 2.6. No, we're not there. And the low one's 1.8, 1.1. So comfortable. Now the statistic models are all much lower. The average says the high of 1.1. That seems ridiculously low. I'm not saying it won't happen, but look at the disparity between 1.1 versus 2. That's a whole degree pretty much spread. So we'll see. We'll see. Just data for you to make up your mind. And just, if you want to put a bet, or not a bet, but just a wager, stake your mark in the comments section of the video and let us know what you think. Are we going to be at 2? Are we going to be at 2.2 degrees? Or are we going to be 1? Or are we going to go back into La Nina? I know a few of you like to troll and say, yeah, we're moving back to La Nina. I don't know that that's going to happen, but let us know what you think. All right, so let's try to summarize real quick here. New developments. Weekly building cloud pattern. Negative outgoing long wave radiation continues near the dateline. It has been since June. Okay, evidencing of the upflow of the Walker circulation there. But the operative word here, weekly. It's not strong. Equatorial current suggests Walker circulation stronger effects at the surface. Yeah, according to the equatorial current, things are looking good. The North Pacific jet stream is holding steady. It's seasonal, maybe a little bit stronger than seasonal, but nothing really impressive happening there. That said, we think the seasons are delayed by 6 weeks just by La Nina, the lingering effects of La Nina. And if that's the case, if really the jet stream is indicative where you would want to be in July, then we're in great shape. Just something to consider. SOI has backed off some. We know that because of the Southern Oscillation Index, because of the pending development of the inactive phase of the MJO. West wind anomalies have been holding over the Kelvin wave generation area since 715. I mean, that's a pretty good place, really, where we are if you're just looking at west wind anomalies. And then moving on, a new Kelvin wave is developing. Okay, that's good. The ENSO models all suggest more of the same moving forward, though the CFS model has downgraded slightly, and I think it will continue to downgrade the longer it takes for the Walker circulation to get established. That's everything right now. We're waiting for that magic sign on, somewhere around the dateline to a point south of Hawaii. We want to see outgoing long wave radiation get much cloudier there and suggest there is uplift going on, and we're not seeing it yet. And now we have the inactive MJO arriving, which is only going to stall things for another 2 weeks. So where does that put us? Here's my best guess. Is the Walker circulation building towards El Nino? I still say yes, it is. 75% positive, 25% negative. But it's just slow. Will the west wind anomaly pattern continue over the Kelvin wave generation area? Yeah, I'd say 70% it's going to. With perhaps a 2-week stall, that's probably even overstating it. Are more Kelvin waves in flight or expected? Sure, one more is already on the way, guaranteed. Is the ocean and the atmosphere coupled? That is the million-dollar question. I'd say we're getting there, but we're only 60% of the way there. We've got 40% more to go. Will the warm water pool in the east discharge before coupling occurs? I'd say no. There's just way too much warm water there, and we got another Kelvin wave in flight. That ain't happening. The 20% is probably an over the top. It probably should be 10 and 90. Now, is the model guidance believable? It's a model. We're looking out weeks and months at a time. I'll give it 65% confidence level. All right, so let's get out of the details. Let's zoom up real quick. So what's going on? Well, the good news is it looks like, hey, maybe another southern hemiswell, a semi-legitimate southern hemiswell, if not maybe a pulse of them might develop. Give it about 4 or 5 days and then about a week after that to get up to California. So potential for surf. North Pacific, nothing really happening. The Jetstream looks pretty good, and if you consider the fact that we're probably 6 weeks behind schedule given La Nina, it's actually in really good shape. Looking longer term, of course, everything is all about El Nino. The stronger the El Nino, the stronger the Jetstream, the stronger the storm pattern in winter months. We don't want to get too much of an El Nino, though, because then it just turns into a blown-out windy mess in California and even Hawaii for that matter. We don't think that's probably going to be the case, given that it just doesn't seem at all possible we're moving into super El Nino status. I think we're going to be somewhere in the middle of the strong category, 1.7, 1.8 degrees above normal, which is good enough to certainly support storm development and give us a robust winter experience. Though I'm thinking, given that we are having a little inactive phase of the MJO for the next week or two, that the real development of El Nino isn't really going to get going till, we'll say, September 9th, somewhere between September 9th and September 15th. I think we're going to turn the corner and things are going to get real interesting. So the next couple of weeks, 2 to 3 weeks, are going to be very interesting. We'll follow closely. You can follow closely too. Just use stormsurf.com and look at the models, and if not, follow along on the videos. Now, to be clear, next week there will not be a video, and I won't be able to make it up. There's just things going on in life that are going to overtake me, so sorry about that. But then we'll be back, and we'll give you an update when we get back. If you enjoyed the video, give us a thumbs up. There's my thumb. If you have any questions or concerns, be sure to write them up in the comments. Let us know what you think, how hot the Nino 3.4 sea surface temperatures are going to get. Give us an idea. You know, maybe all of us putting our heads together is certainly better than just one of us. And then if you want to donate a little money, you can, but not required. But it certainly is appreciated. And other than that, I think we're moving in the right direction, just slowly, too slowly for my preference, but we're going to get there. All right, go surfing if there's waves, make the best of it, have some fun. We will see you in 2 weeks, and thanks for watching.